In this integral, we notice that there is a negative exponent. Our strategy is going to be to eliminate that negative exponent. And to do that, we are going to multiply the numerator and denominator by e to the 4x. And we're going to do that because e to the negative 4x times e to the 4x is 1. So in the numerator, we are multiplying e to the 4x times e to the 4x, so we're going to add the exponents. In the denominator, we will be distributing, so this e to the 4x gets multiplied by each of these two terms in the denominator. That will give us e to the 4x times e to the 4x, which is e to the 8x. And then negative 3 times 1. E to the negative 4x times e to the 4x is 1. So this is multiplied by 1. And now we have this expression. Let's simplify that, and then we will figure out what our next step will be. So what I notice is that in the denominator, we have an exponential expression, and I notice that its derivative is almost the numerator. And we have a property that we've been calling log property, and that is this. If we have a quotient where the derivative of the denominator is in the numerator, this will always integrate to the natural log of the absolute value of the function in the denominator. And so it's very strategic if you can keep this log property in mind. When we look at this function here, if we had an 8 right there, now the numerator is the derivative of the denominator. The derivative of negative 3 is 0. The derivative of e to the 8x is itself multiplied by the derivative of the exponent. Now, if we just pop an 8 in there, that's going to offset the value, so we have to counter that by dividing by 8. If we multiply the numerator by 8, we need to multiply the denominator by 8 to preserve equality. And now we're good. Now we are in log form, which I usually will try to indicate by putting something like LF. So it's in log form, and that's going to give us the final answer of 1/8 natural log absolute value of whatever's in the denominator plus c. So there is how we deal with negative exponents and log form all in one fell swoop.